Hi guys, this video is going to go over the worksheet that we have on the AP review questions for the two-dimensional kinematics. So let's start off with number 1. The velocity of a projectile at launch has a horizontal component of v sub h and a vertical component of v sub v. Air resistance is negligible. When the projectile is at its highest point of trajectory, which of the following shows the vertical and horizontal components of its velocity and the vertical component of its acceleration? Okay, so let's say you have a projectile. At the beginning, it says it has a velocity, and it doesn't say exactly what that is, but it says it has a horizontal component of v sub h, and it has a vertical component of v sub v. When the projectile is at its highest point of its trajectory, which of the following shows the vertical and horizontal components of velocity and vertical component of acceleration? Okay, so we've been talking about how the horizontal component is going to stay the same the whole time. So even at the top, it is going to have a horizontal component of velocity. But when it gets to the top, down here it had a large vertical component of velocity. It gets smaller, and at the very top, its vertical velocity is 0. And then the last part of the question is, what is the vertical component of its acceleration? Well, the vertical component of acceleration is always the acceleration due to gravity. And so that's what we have going on here, is the acceleration due to gravity. So we look at our options. I'm going to start off with the last column because the vertical acceleration has to be gravity, so those don't work. So now I'm down to C and D, and they're both the same in this column, but in the middle, the horizontal velocity, it does have a horizontal velocity, and so number 1 is D. Number 2, I left myself a lot of space on number 2. You don't have as much space on your worksheet. If you wanted to do a separate piece of paper, you could. Let's take a look. A target T lies flat on the ground 3 meters from the side of a building that is 10 meters tall. So here's our 10-meter building. Here is a target 3 meters away. A student rolls a ball off the horizontal roof of the building in the direction of the target. Air resistance is negligible. Horizontal speed with which the ball must leave the roof if it is to strike the target is most nearly. So in other words, we are looking for the horizontal speed. That's v sub x. That's what we've been calling it. So this ball is going to come here, and it is going to fall down to the ground and hit the target. All right, when we do these problems, we have things in the y direction, we have things in the x direction. And so v sub x is what we're looking for, but we actually have quite a bit of work to do before we find v sub x. I'm going to erase that just for now because I'm going to start with my y direction. In my y direction, I know that my delta y is negative 10 meters. It falls down 10 meters. I know that in the y direction I have acceleration due to gravity, which is I can use a negative 10 on this test. Also in the y direction, I need time. I don't have time, I need time, so I'm going to find time. That should be enough for me to start. If I look at my equation sheet, I want to use this equation. Now, the initial velocity in the y direction is 0. So in the y direction, that initial velocity is 0. I can cross that out. And so what I have is delta y, which is a negative 10, is equal to 1/2 the acceleration due to gravity, t squared. So now I just need to solve this out. Okay, so I work it out and I find out that t is the square root of 2. I could change that to a decimal, but when I'm looking at my answers, there's a lot of root 2's in there, so I might just leave it in that form. Okay, that was all in the y direction. Now I need to think about my x direction. Well, my delta x is 3 meters. My speed in the x direction is what I'm looking for. I did just find time a minute ago, and the time in the y direction is the same as the time in the x direction. Because in the x direction it is a consistent velocity in the x direction, doesn't slow down, it just stays the same. Because of that fact, I can use my definition of velocity formula and just find it from there. So my velocity is 3 divided by square root 2. That is actually one of the answers, and it is C. Okay, number 3, we have not really talked about number 3. I can put a link in the Google Classroom to an activity that will help you out maybe a little bit with number 3, but the concept that's shown in that link is that if you're shooting something from a certain place, the angle with which you shoot that, let's think about some extreme cases. Let's say you're shooting it at like an 80-degree angle. Okay, it's going to go really high, right? But probably not very far. If you're kind of more in the middle, then it's going to have some height and some length. And if you have a smaller angle, it's not going to go very high, and it's also not going to go very far because it's not going very high. It doesn't have very long in the air. As it turns out, angles which are complementary will have the same landing spot. In other words, if I have a 60-degree projectile and I have a 30-degree projectile, they're going to land in the same spot. If I have a 20-degree and a 70-degree, they're going to land in the same spot. So anytime you have complementary angles, they're going to land in the same spot. And so we know that that kind of works its way down to the 45-degree angle, which would kind of be in the middle of both of them, right? So that 45-degree angle is sort of an optimum degree to get it where you want it to go. That ties in here. An object thrown with velocity v from the edge of a cliff above level ground, neglect air resistance in order for the object to travel a maximum horizontal distance from the cliff before hitting the ground. The throw should be at what angle? Well, if it's greater than 60, it's going to go really high up, but maybe not very far out. If it's between 45 and 60, kind of a similar deal. It'll go higher, but maybe not as far as you want it to go. If it's greater than 0, but less than 45, okay, let's think about if it's 0. If you just throw it straight, it's not going to have a very high trajectory, and therefore it won't have very much time to be in the ground or in the air, and so it's going to hit the ground sooner or closer. So you need to have it above that, so it needs to be actually greater than 0, but less than 45 degrees above the horizontal. This last one, that doesn't make any sense at all, does it? You throw it this way, it's just, going to hit the ground straight away. I'll show you that link and show you how that is going to work. Okay, number 4 is also going to need some space. So I've created myself some space. If you want to do it on a separate paper, you can, or if you just want to try to squeeze it in here, you can do that too. Because I have a little bit of space, I'm going to draw a diagram. Okay, so you shoot an arrow, you aim it horizontally directly at the center of the target 20 meters away. However, the arrow hits 0.05 meters below the center of the target, so it misses it, which makes sense because what's happening is the arrow has a horizontal trajectory, but it's falling also. Each time it's getting a little bit lower, even though the velocity vectors are staying at the same height, they're falling down a little bit. And so that makes sense. It's going to hit it a little bit lower if you're shooting it directly there. You ought to shoot it a little bit higher in order to hit it. Okay, and neglecting air resistance, what was the initial speed of the arrow? Well, once again, we need to think of we have to think of the x and the y components. So we have an x component of things going on, we have a y component of things going on. Let's start off in the y direction. In the y direction, we know that it falls 0.05 meters. That's what it's falling. We know in the y direction we have the acceleration due to gravity. What we need in the y direction is the time. And we have enough information here to give us the time. So once again, I'm going to use this equation to find the time. The initial velocity in the y direction, all of this is y, initial velocity in the y direction is 0. I know my change in y is negative 0.05 meters. And I know that my acceleration, I'm going to use a -10 for my acceleration, and my t is what I'm looking for. So I solve it in the y direction, and I get t to be 0.1 of a second. All right, that's helpful. I now am going to transition over to the x direction. And in the x direction, I am looking for the velocity, and that stays consistent throughout. I know in the x direction that I have 20 meters away, and I just found the time, and the time is the same in both directions, so I don't need to distinguish that. So I have this information. Because in the horizontal direction the velocity is consistent, I can use the definition of velocity. 20 divided by 0.1, so my initial velocity in the x direction is 200 meters per second, which is d. Okay, number 5 goes back to a little bit the same concept I was talking about. At what angle would it go the farthest? So 2 arrows are launched at the same time with the same speed. Arrow A at an angle greater than 45 degrees and arrow B at an angle less than 45 degrees. So arrow A is going to go here. Arrow B is going to go here. We don't know the angles, but we know B is less than 45 and A is greater than 45, and we know they have the same speed. They both land at the same spot on the ground. Which arrow arrives there first? Okay, look at their trajectory. B is going to land there. A is also going to land there. But which one has the greater total distance to actually fly? Okay, the reasoning is B doesn't go as high, so it travels a shorter distance, so it's going to hit the ground first. Okay, questions 6 and 7 both deal with the same paragraph here. During a recent storm, bales of hay had to be dropped from an airplane to a herd of cattle below. Assume the airplane flew horizontally at an altitude of 180 meters with a constant velocity of 50 meters per second and dropped 1 bale of hay every 2 seconds. It is reasonable to assume that air resistance will be negligible for this situation. Okay, let's see what's going on here. We have an airplane. Our airplane is flying at 50 meters per second, and it is 180 meters off the ground. It is going to be dropping these bales of hay. And when it drops a bale of hay, it is going to have a horizontal velocity immediately of 50 meters per second. Its initial vertical velocity is 0, but then it's going to have gravity and it's going to gain momentum or gain acceleration and become faster. And then 2 seconds later, it drops another one, which has the same conditions on it. It has a 50 meter per second horizontal, 0 in the vertical, but it has gravity, and gravity is going to act upon it to bring it to the ground. And air resistance is negligible for this situation. Okay, this is similar to a problem we had on the last review, I think. If this bale of hay is dropped, and let's say 2 seconds later it gets here, and so that's there at the time that this one is actually dropped. When that happens, in the next second, this one is going to travel this distance, whereas this one has this tiny little distance to go. And then this one's going to travel even farther in the next second, and this one's just going to go this far. So they are getting farther and farther apart. The distance of separation will increase. And like I said, that was a problem that was similar to one we had on the last review. Okay, about how far apart from each other will the bales land on the ground? So these are dropping. I'm going to erase some things here. Okay, these are dropping, and as they drop, it has some horizontal velocity. It has some, in the y direction, it's going to gain velocity, it's going to accelerate. And they're going to do this, but it's every 2 seconds, and they're going to be equally spaced because they're every 2 seconds apart. Well, basically the question is, how far does it go, or how far does the plane go in 2 seconds? Well, the plane is going 50 meters per second, and it's going for 2 seconds between drops, so the bales of hay are going to drop 100 meters apart from each other. All right, that is the multiple choice side of the handout. I will address the free response in the next video.